Let's recap solving trig and radians. So we're going to go over the rules that you learn in year 12, apply them to radians. Then we're going to solve 3 key questions to make sure you guys got it. Got it? Let's go. So, how do we solve trig and radians? One thing we do not use is cast diagrams. If anybody wants you to solve trig with cast diagrams, they misunderstand what cast diagrams were actually made for. They're only made to describe when a function, a trig function, sine, cos, or tan is positive or negative. That is it. They are not, well, they were not made for solving, all right? So, any real mathematician does not use cast diagrams to solve. They would use a graph, or they just know what the rules are based off of the graphs. So let's just observe the graphs again. So let's look at the sine function. Now I'm going to first do this in degrees just to remind you guys. So here's my sine graph. So it starts off at 0, you have 180, you have 360. Now when you do inverse sine of a value, it will always give you a value between minus 90 and 90. And you guys will learn this later on. It's to do with the inverse functions and the range of the inverse functions. But for now, let's just focus on, if you do inverse sine, it's going to give you a positive number. So for example, inverse sine of a half. Inverse sine of a half is 30. Now this is known as the primary value. Okay? How do you work out the secondary value of the function? Well, you just read across, look. You can see there is another value. Now the sine graph is symmetrical about 90, meaning these two distances at the end are the same. So 30 in this way will be 30 in this way. So you're doing 180 minus 30, which is 150. And that's the rule. This is known as the secondary value. In degrees, so in degrees, once you know the primary value, which is just doing inverse sine, you just do 180, take away the primary value. So based on that, how would it be in radians? Well, we know in radians that 180 is equal to pi. So in rad, we have pi minus the primary. Okay? How about with cosine? So the cosine graph looks like this. In degrees, this is 90, 270, 360, and 0, 1 and minus 1. Doesn't matter. Let's use the example of a half again. Yeah, we'll just do a half. Now, inverse cosine of a half is 60. Okay, that's our primary value. Then when we look across, yeah, we can see there's symmetry. So you could say this is 60 in. So always look at in. Okay, so in 60, the reflection here is at 180. So in 60 this way, which would take you to 300, and that's your secondary value. So for cosine in degrees, all you do, once you know your primary value, is you do 360, take away the primary value. So what would that be in radians then? Well, we know in radians, 360 is the same as 2 pi. Super easy. Let's do the last one, tan. So the tan graph looks like this between 0 and 360. So we have 0. This would be 180. And this is 360. Okay? For this sake, I'm going to do inverse tan of 1. Now, inverse tan of 1 is 45. Now, where else do you see this point? Is over here. So this is our primary value. That's 45 in. Then we're going to move across to the 180, and it's 45 in again, which is 225. And that's how you work out the secondary value for tan. So in degrees, for tan, you do 180 plus the primary value, which means in radians, it's pi plus. Okay? Now, what I've done has been for the range 0 and 360. Obviously, we can have much bigger ranges. Well, once you've worked out the primary and secondary value, yeah, so primary, then you just do all of this depending on what we're talking about. All 3 graphs repeat every 360 degrees. So all you need to do is, once you have your secondary, yeah, so you have your primary and your secondary value written down, all you do is add and minus 360 if you're in degrees. We'll practice this in a second. And in radians, once you have your PV and SV, you plus or minus 2 pi. Okay? Now some of you might be saying, wait, for tan, I thought it repeats every 180. It does, but technically, because we've worked out the secondary value, we just add 360, we follow the same procedure. But it's up to you if you want to use this. I don't recommend it for my students because you already have enough things to kind of remember in the exam. But once you have this, you can just keep adding 180. So for tan, you can add and minus 180 if you want. But I like to stick to, look, find the primary and secondary values, because you're going to do them anyway, then just add and minus 360, okay? Now, in terms of what real mathematicians do when solving, drawing the graphs is totally acceptable. If you guys like drawing the graphs, I have no issue with that. But because we understand the graphs, most mathematicians will just do this, okay? Because they're just not trying to waste time, all right? Especially when you're in a pressurized environment, guys, you don't be wasting time drawing graphs. So stick to this, add a minus 360, that's it. One thing, like I said, that us mathematicians absolutely do not do is use the Cos diagram when solving. So let's do some questions. I'll write down the rules again so we can follow them step by step. And I'm going to do some key questions that I think will be useful for you, especially if you're just starting out looking at radians. So to work out the secondary value for all functions, do you remember them? Maybe you can try and recite them as I'm writing now. For sine, pi minus the primary value. I'm going to write them in radians to really test you guys, be thinking about those conversions, all right? For cos is 2 pi minus, and for tan is pi plus. Then, once we have that, we add and minus 360, or 2 pi. So the first question I wanted to go through with you guys was a nice and easy one, kind of, is solve sine 2x is minus a half, and the range I'm giving you guys is between 0 and 2 pi. What's 2 pi? 360 degrees, remember. Okay, so let's follow the same procedure as always. Now, if you saw my previous video where I showed you sketching functions, the first thing we should always be doing, even in year 12, is modifying the range. The range here is for x, we're dealing with sine 2x. So we're going to modify the range. We're going to modify that range so that says 2x, not, says 2x, not just x. Okay, so let's go to this. First thing we're going to do is going to do inverse sine of minus a half. Now, inverse sine of minus a half is minus pi over 6. That's my primary value. And this is going to be my next tip for you guys. You have to decide whether this value fits within this range. Now, the disadvantage we're at now is that this is over 6 and this is not over 6. So I recommend you change this range. So it doesn't say 4 pi, it says something divided by 6. What divided by 6 is 4? It's 24. Oh, wait. Yeah. Yeah, so 24 over 6, and then this is just 0. So this is obviously not in the range. But because it's not in the range, it doesn't make a difference, okay? So we're going to go with our principle. We're going to do pi minus. So to work out my secondary value, I'm going to do pi minus pi over 6, which becomes pi plus pi over 6, which is 7 pi over 6. That's my secondary value. That is in the range because 7 pi is less than 24 pi. Now, we're going to take both of these values and we're going to add and minus 2 pi. So for minus pi over 6 and 7 pi over 6, make sure you write the primary and secondary value first. We're going to add 2 pi to both of them. Okay? So adding 2 pi is like adding 12 to the numerator because it's 12 over 6. So minus 1 plus 12 is 11 pi over 6. Is that in the range? Yes. This, when you add 12, you get what? 19 pi over 6? Which is also in the range because it's less than 24 pi. Can you keep going? Yes. Because if you take this and add 2 pi, When you add 12, you get 23 pi over 6. Okay, that is in the range. So the primary value was not, but it helped us work out all the other values which are. Now to all of these values, we just need to divide by 2. So x is 7 pi over 12. Then we have 11 pi over 12. And 19 pi over 12. And the way I'm kind of structuring my answer is that all my answers perfectly go in order. Which you don't have to do. But when students don't do that, I get triggered, I can't lie. Okay, so that's that question. Let's go ahead and solve the third one, where I can't remember what it is, but maybe it would involve a little bit more manipulation. I basically want to just test out all the key skills from year 12, but just apply it to radians, isn't it? So what's the next one that I had planned? Solve 4 cos 4x plus 1 is 0. So solve, I'm going to say the range next. X is between 0 and pi over 2. I want to solve 4 cos 4x plus 1 is 0. Yeah. So when solving something like this, we first need to rearrange for the trig function. I don't modify the range just yet. I just rearrange for cos 4x first. So I'm going to minus 1 divided by 4. And I get minus a quarter. Okay, now I'm going to modify the range. Cos 4x, I'm just going to do it here. My modified range is going to be between 0, 4x, times that by 4 is 2 pi. Okay, usually they do that. They make the range smaller when these angles get bigger. Now we have to do inverse cos of minus a quarter. Inverse cos of minus a quarter, and I'm in degrees, so in radians, is 1.82. So we're going to get 4x is 1.8234 dot dot dot. That's our primary value. Now I want to use this for later. Okay, so I'm going to store this value. Now I have the 991EX, which is still the best calculator that's ever been made. And above my 7 says STO. So I'm going to press STO, then the button above it, it stores this as A. So I can reuse it later. If you have the CW, I think it says like variable or something, and you can store it as one of the letters like that. Okay, so now that we've got the primary value, the problem with this is I can't really compare that to 2 pi. I mean, you can, but really if you decimalize it, you can easily compare. So when this answer is a decimal, I recommend you decimalize the modified range because then it's easier to compare. Now, I'm just going to be brief here and say pi is about 3.14. So 2 lots of that is about 6.28, okay, which that clearly is in that range. Now for cosine, how do you work out the secondary value? 2 pi minus. Okay, so I've stored that. I'm going to do 2 pi minus the answer, and I'm going to store that as b. So that is 4.459 dot 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 SV. I've stored that as b. Now the next thing you have to consider is, can you add or minus 2 pi? Well, think about it. My range, my modified range, is between 0 and 2 pi, right? Now both of these are in the range. This is 1.8. This is 4.4, say. Now the range's size is 2 pi. So if you add 2 pi to both of them, they're obviously going to come out, right? So you do not need to add or minus 2 pi for this question. The only thing we need to do is we need to divide by 4. And I haven't set what decimal to do here, but I'm just going to do whatever I think. I get 0.455, etc. So I've done a divided by 4, by the way. I'm just going to do 2 decimal places, 0.46. And then I just change that quickly to b. And I get 1.11. Super simple, right? Okay, cool. No class diagrams have been used. Let's go ahead and do the last question that I wanted to do with you guys. I might need to write on the other side though, because it might be a longer one, but we shall see. Solve. Okay, solve, I'm going to do it here. Solve between this and 2 pi. 2 tan squared x minus tan x minus 6 is 0. Okay, so I'm basically going over a year 12 concept of solving quadratics in trig, but then we need to apply it to radians. And obviously I've done a sine, cos, and tan one for you guys. So if you guys want, you can just solve that quad function as it is. Or what most students do is they make a substitution. Now I use u, which makes the most sense because when we do integration by substitution, we always use u as the substitution. We don't use y because we usually use y for other things. So I get 2 u squared minus u minus 6 is 0. We can factorize this now. From year 12, you can use your factor theorem, basically use the calculator to do this for you. But there's going to be 3 and 2. The 2 can't go here. It's going to be this. That gives me, the 6 and, ooh, I think it's going to be something. Wait, I just said the 2 can't go here and I end up writing 2 in the first bracket. This guy, man. Okay. So that gives me 4. This gives me 3. So this means minus and plus. So 2u squared minus 4 plus 3, then that's minus 6. So I get u is minus 3 over 2, and u is 2. You know, you're thinking, oh wait, they're not between 1 and minus 1. Remember guys, it's tan. Tan goes up to infinity and minus infinity, Buzz Lightyear in that. So tan x is minus 3 over 2. Tan x is 2. Okay, so we got our calculator. I'm going to do inverse tan of minus 3 over 2. So I get x is minus 0.9827 ... That's my primary value. I'm going to store that as a. Okay, now for tan, how do you work out the secondary value? Pi plus. So pi plus answer, I get 2.158 ... That's my secondary value. Store that as b. Now this is not in the range, this is. The range starts at 0. So what do? We're going to add 2 pi to both. But this is already in the range. Remember that number line I showed you? Since this is already in that range of size 2 pi, by adding 2 pi, we're going to go out the range. So I'm only going to do it to the primary value, which I stored as a. So when I do a plus 2 pi, I get 8. Wait. My a, did I store a? Ah, no, I didn't store a. Inverse tan of minus 1.5 is that. Store is a. Add 2 pi, 5.300. I'm going to store that as c. Not that I need it to store as c because these already equal x. But I just do it just in case. Okay, so we have 2 solutions. Now we're going to do inverse tan of 2. So I get x is 1.107. That's my primary value. I'm not even going to store that. Pi plus the primary value, because this one's nice and easy. 4.248. That's my secondary value. Now these are both in the range of size 2 pi, so you're not going to add and minus 2 pi. So my 4 solutions now, I'm going to do in order. I'm going to say 1.11. I'm going to say 2.16. I'm going to say 4.25. And I'm going to say 5.30. So if they say 2 decimal places, guys, you have to put the 30. You'll lose a mark otherwise. But that's it. Guys, that is how we solve in radians, going over all the rules. You don't need to draw the graph. You definitely do not need to use the cast diagram. So if you learned something today, I'd appreciate if you hit the like button, subscribe for more maths content. If you're interested in my A-level maths courses, link is in the description. And you can join the Lund Gang Reddit page if you want to submit your own questions. I'll see you in the next video. Nice.